right. Welcome, everyone. This is, I hope, is a fun one for you, metacognition and your students. This is something that I've started using a lot in my instruction. So I've been teaching now for 30 years in marine science and marine geology, and I am the program manager for TA training here at the university. So I know lots of names here. So I'm happy to see a lot of y'all here. What I want to do with y'all today is talk about what metacognition is. And I think that probably a lot of you, or many of you, are at least somewhat familiar with what it is. But I also want to talk a little bit about learning. And this is not a cognitive psychology webinar at all. I do not have the chops for that. That is something different. But I am going to touch on a few things about what students believe about learning often, and often they're mistaken, and then some principles about learning and metacognition that go together. And then we'll be looking at a bunch of strategies for using metacognition in your classroom or in tutoring or in coaching. This is all stuff that can be used in so many different realms of your life. So hopefully you'll get some good ideas from that. So let me ask you, I have a question for you. Which of the following that you see here do you think is the most important for successful learning for your students? Is it the intention to learn? Is it practicing memorization to increase memory ability? Is it learning in a way that matches your personal learning style? Or is it distribution of practice in learning facts and skills? So across like week or 2 weeks. Or is it the time you spent studying? So put into the chat what you think is the most important thing for students for successful learning. A, B, C, D, or E. Or more than one if you think there's more than one. A, okay. D, time and intention. Okay. Time you spend. So A and E. A, D. Yeah, maybe A and D. I am putting into practice a metacognitive strategy right now. A, okay. What else do y'all think? What is most important for successful learning? A, C, and D. So intention, personal learning style, distribution of practice in learning facts and skills. Okay. All right, y'all ready for the answer? The answer is the distribution of practice. And so I love that so many of y'all did not say that, because that's the whole point of doing these types of professional development sessions, is to help you understand what does work in the classroom and what is the research, those practices that are research-based. So we all have good intentions to learn, and that I can understand why some of you may have selected that, because you want students to have intrinsic motivation. And that is an important aspect, but in the end of how much learning happens, there's a lot more to it than that. Practicing memorization, turns out memorization and increasing memory availability. There's research that shows that by just practicing memorization, you don't actually increase how well you are memorizing things. And of course, there's always little caveats to all of these, but in general, just by practicing memorization doesn't mean that your memory gets better and better. And I can tell you that, that's for sure for myself. Learning in a way that matches your personal learning style. For those of you, if you have looked on the CTE's CTE YouTube channel, I gave a workshop that I recorded a webinar on how learning styles are a myth. There's a ton of research that talks about that. And I'm happy to, if you want me to give that webinar to you or your department, it's a really fun webinar to do, because you get to see what your quote unquote learning style is and why it might be not actually accurate for you. And then the time you spend studying, it's more the efficiency and the effectiveness of the tools that is used rather than the actual time. And so what y'all are going to see today is this idea with D, distribution of practice. This is a technique. It's a recommended research-based technique among many that should be used, or students should be aware of, and y'all should be aware of, as to what works for better learning, for more successful, more effective learning. Okay, and please do feel free to ask questions as I go. I don't want to wait until the end to have y'all ask questions. I want this to be a much more engaged session for all of you. All right, So the whole point of instruction for us and for students is to make sure that, or try to get students to have long-term learning. So this includes retaining it, remembering it, of course, but also being able to apply it in new situations down the road. What we often, though, see, and this is from some really interesting research, is that what students are doing in class during the lessons that they're doing is really just temporary, what they called temporary performance. So they're doing practice in class, but then it's not actually being retained in long-term memory or in application. And I'm saying this as a general comment because many of you may actually be using strategies to help increase student learning, whether it's active learning or case-based learning, those types of things. This is just talking in general, what we see about what students seem to be doing rather than what they are doing. Answering the question of why do students think that they're learning and they actually haven't. So what we tend to see instead, as I said, temporary performance is this short-lived knowledge. It's not actual true long-term learning or deeper learning with our students. You know, they remember, they cram and they forget. I remember doing that whenever I was a student in undergrad, and I don't remember anything. Students think that they know more than they have, more than they do, more than they think that they actually were studying. And that's a pretty common conception for students who thought they did well, you know, and then they find out that they didn't, and they're upset as to what it was that what went wrong. And that goes to the idea of they need to know what works for them and what has been shown that actually works. And then, of course, students are often just more focused on the grades than the actual learning itself. And I'm sure we have all seen that. So what students don't know, why is it that students think they know more than what their grades represent? There's what I call, just based on me developing this webinar and doing the background research, I think you may have heard hidden curriculum with respect to first generation students or international students or graduate students. I think there's also a hidden curriculum of learning, of what it takes to be a good learner, to be able to make sure that you do remember things, learn things well. So things like how memory works. So I don't know if we have any psychologists or cognitive science folks or neuroscience folks here, but or anyone, does anyone know how memory actually kind of works? And I know that's a whole workshop in itself. But what is it that you have to do with memory when you're trying to learn something? Can anyone put that into the chat? If you can think about what that is or what you've heard about with memory. And I'll go ahead and move forward, but go ahead and type in the chat. So yeah, rehearsal. Yes. What else have you heard about memory, how it works? I wish I had learned this whenever I took psychology. Well, I may have learned it. I just don't remember because I didn't learn it right the first time. Um, Students don't realize, I think, or they should realize, engaging previous knowledge. Yes, we're going to be talking about both of those, actually. Learning is hard. It's not something that should necessarily come automatically. They may think it should be, but good deep learning really does take work. So active recall helps retain information. Exactly. And if you do a search about how memory works online in some of the psychology journals or just generally like in Wikipedia, there's short-term memory, there's long-term memory, and you have to make that short-term memory get what they call consolidated into your long term. But to do that, you have to do these things that were just mentioned: rehearsal, engaging knowledge, active recall, really actively, purposefully doing things to make that go into long-term memory. Yes, exactly. Thank you. Repetition, retrieval. Another hidden curriculum is what is required for real learning to happen. So, again, how memory works, but what are some things that students need to be doing? What doesn't work with respect to learning and studying, and what they need for themselves. Everybody is different in how they learn. I'm particularly a reader, and I like to write and rewrite my notes. That's just how I learn, but different people learn different ways. And it's not that there's a style, you have a learning style, which is not a thing. You just have a lot of preferences. Preferences is kind of the better word to use that does work for you. And then what I think is interesting is that students' intuition as to what works isn't correct, isn't often correct. And that's because they don't know about metacognition. They don't know what those misconceptions are as they're learning, as they're studying. And one way to go about addressing that is to help students learn about what metacognition is. Okay, you may have heard of the forgetting curve. Students think that, and I'll talk about this a little bit later, but when students have something, they learn something, the actual loss of memory over time is actually exponential unless you do things such as retrieval, active recall to consolidate that back into your memory. And there's tons of research that shows that. So what metacognition is, there's basically a cycle. There are steps that you do or students do. So you're thinking about how you think, about the ways that you think, the things that you need to do. So it requires that students and learners do planning. So they're thinking about what it is that they need to do, how to approach a particular task or skill building activity or a learning module, whatever it might be. It then requires monitoring, so paying attention to what they're doing. Is it working or not? Are they making progress? Do they have understanding? And we'll look at some study techniques that don't work, that are not students think that what they're doing is monitoring or doing good studying habits when it actually isn't working or not. So knowing what those are is important. And then evaluation. What did I learn? How effective was that strategy that I used? Should I try something else? And through all of these stages, there should always be reflection on what is that's happening. Is this working? Should I adjust now? Can I adjust later? All of these incorporate some level of reflection in the learner. Okay. All right, so there are these two dimensions of metacognition. You're going to see both of these scattered throughout a lot of the practical applications that I'm going to show you what you can do, and also in some of the recommended strategies. So there's what we call the metacognitive knowledge. So just knowing what your abilities are, what it is you need to do in order to do deeper thinking or have effective learning. What are those strategies that you need to do? So this is something that we as instructors, as coaches, need to talk about, and I'll mention that towards the end as well. And then there's the regulation of oneself. So you saw both of these in that cycle that I just showed you. So regulation as a thinker, as a learner. So monitoring yourself, assessing your knowledge as you go, whether the strategy is working or not. You have these two aspects, these two dimensions of metacognition, both working hand in hand for metacognition to be effective, and those strategies that they use. Okay. So let me see if y'all know of, and don't look ahead in the slides. But what do you think are some of our students' mistaken beliefs or assumptions about their learning? I mentioned a couple, but there's quite a few. I want to see what y'all are aware of, what you've seen in your students, their assumptions or their mistaken beliefs about learning. Yes. Oh, yes. More time studying always equates to better learning. Oh, there's such good research out there, y'all, on all of these things. That is real research that shows that. Let's see. If they agree when I say it, then they know it. The nodders. Yes, that's a great comment. What else? What are some other things students' mistaken beliefs or assumptions about their learning, either during class time or when they're studying? Let's see, I teach high school and my students feel that since Google has the answer, there's no need to learn it. Yeah, that's really an interesting comment. So I have talked to my students. I teach marine science to non-majors. And I tell my students, I'm not going to test you over numbers and stuff, or dates or values or whatever it is. And I say, because I don't remember those, that is what Google is for. But the actual deeper learning and making connections and some other things that I'll talk about in just a little bit, that is something Google or Gen AI can't do for you well. It's a really good point. Or yes, exactly. You're thinking exactly what I'm thinking. Any other things that you see your students are making mistakes about their learning or their testing or how they do assignments? anything like that. Yes, cramming right before an exam, being able to pass it means you learned it. So not true. Oh, case in point right here, so many times during my undergrad. Yes, exactly. Good. Writing the vocabulary is enough for studying the terms. Yeah, absolutely. That is studying to them. And I mentioned that I like to write and rewrite things, but there are things that I'm doing as I'm doing that, metacognitive strategies that I'm doing to make sure that I'm learning it well. Okay. A little specific to my field, but complex vocabulary is good writing and higher understanding. Yeah. And could relate to what was mentioned earlier, ChatGPT can do the same thing. That's right. Great point. All right, good. Let's look at some of these and some of these that the research talks about as well. These mistaken beliefs, which are called metacognitive illusions, which I really love that phrase. So often they think that they're doing a lot better than they think they are, that they actually are, for example, on exams, or they think they wrote a great paper because there was like you just said, a lot of good vocabulary or a higher level good writing in there. Um, they have a judgment, a flawed judgment on how well they understand a text. And so there's some interesting research that recently came out, and I'm going to talk about it a little bit at the end today, but they have shown that students who read text on paper actually have better understanding through testing and assessments, experimental testing, than if they read it on a screen. Even if the screen is multimodal, they actually are not learning it as well as if it's actually on paper. And I just saw that paper yesterday, and so I haven't had a chance to read through it, but this came out a couple of years ago. Yeah, that's awesome. I know, right? I'm like, this is why I print everything out. I'm a hard copy person, and this just supports that so well. Yeah, that's your Roman Empire. That's awesome. That if learning feels easier, and someone, when y'all mentioned this, a student will often think it's working if it's easy. Students will choose being easier than more effective, because more effective is hard. Learning is hard sometimes. And so that's, as y'all mentioned, cramming, shallower surface strategies, and they'll often misjudge how long it takes to do something, to study some way or do some reading or doing a review, because they just don't have a good idea of how long things do take when you're doing effective learning. Okay. Let's look at some more. How to learn new concepts. So there's a lot of misconceptions on best ways to learn new concepts, things that need to be addressed prior to and during learning new concepts. What I've shown you here is, so one of y'all mentioned this repetition. Repetition leads to learning. Students believe that. That's actually not the case. There is evidence, some really interesting evidence that shows that just by repeating your knowledge, repeating over and over the vocabulary terms, doesn't mean it was consolidated into your brain. The way to do that, and that can be also what is called massed presentation or massed learning, where you study, a certain thing all in one time, all of your vocab one day, and then you do something else, and you think because you studied it all or repeated it that you've learned it. That's not the case. It's not the way your brain works. It's not the way your nerve cells and your memory works. So there was research that showed that students rated this massing, this blocking, or say you do a whole bunch of examples of a problem, one problem type. You've done a lot of examples. Okay, so I know it. Actually, evidence shows that they haven't learned it well. The other option then is what is called interleaving or spacing. So there's a couple types of these where you space out how you're studying, how you're learning across time. Also, research has shown across different spaces, don't just use the same learning space, which kind of goes against conventional wisdom. And interleaving is then also using different techniques of studying, interleaving in between them. So you're not doing the same type of studying throughout that spacing process. So that actually does students do better on exams and learning by doing it in those types of processes than by just massive, like cramming, massing, blocking their learning. So learning spaces being the physical space that they learn. So I know that I had always heard, always study in the same space or try to study in the space that you take your exam. And it turns out that and this goes to why interleaving and spacing works, is you need to have things happen in between these learning events, whether it's a change in physical space, a change in what you're doing and what you're thinking, so that your brain can have the time to consolidate that information from your working memory to your long-term memory. One way that a researcher I read talked about it was called letting things percolate. You need to go do something else to let things percolate. So like if you're trying to think of an idea or something, y'all may have experienced that yourself. Okay. Fluency illusion. I love this one. So you think that if it's easy to remember, it will always be easy to remember. You don't need to study more once you learn it, what you think you learn it. So there was a phrase that one article talked about called forgetting happens. Students forget that they forget. And so that's why you can't just mass it. You have to do that interleaving or that spacing studies processes, those techniques. And so just even repeating those facts over and over and over to each other in one situation or one instance does not give you any memory benefit. I just think it's so cool how our brain works. Learning styles, I've already talked about that. This is a mistaken belief. Student will say, oh, I'm a visual learner. No, it doesn't work that way. And so if you want more information on that, I have a whole bunch of resources on that. Something else that you may have heard of and you don't want to hear is that sleep is important. Sleep is necessary to cause memory consolidation to happen, for it to go from working memory into long-term memory. It also, there's evidence of cleaning happening, in your neurons in your brain that helps to kind of get rid of fluffy stuff, messy stuff, and really consolidate what's important to know. Okay, so that sleep is important. And that this is what I had mentioned, students understood ideas better when reading on paper, but they thought that they had learned better by using on-screen multimodal, but then the testing happened and they discovered that reading on paper was actually better. Okay. But I want to show you now, talk about some principles of learning and metacognition. And if you've learned about active learning, some of these will sound very familiar because active learning is a type of metacognitive technique to help students learn better the things that they're doing. So a lot of these principles come from these two books that are very well regarded. One is How Students Learn and then How People Learn, and that's gone through a couple of editions. I actually have this How Students Learn one. It's really interesting. But one of those principles is engaging prior understanding. So how do we get students to learn better? What are the principles of how learning works, how metacognition works? So we need to engage prior understanding. In order for students, for us, for learners to build that new understanding and make it stick and make sure that it's correct, you have to address what are those existing misconceptions, preconceptions, existing understanding, existing experiences. And there's just so many instances where I can think of students who, if that engaging that prior understanding didn't happen, they didn't get it. They just never did really consolidate for them. So those preconceptions can be actually a barrier to new learning. They think that they've learned it, they say, oh, I got this. But then when they're in an exam or something, those preconceptions creep back in. So a great example of this is even when students memorize content, when they're faced with an exam or faced with an activity or practice, something or other, they're still using those preconceptions if those misconceptions were not engaged in the first place. So there was a study done where two groups of students, elementary students and college physics students, were tasked with doing this exercise where they had to hit this ball to make it hit a target, so it would roll and hit a target. But by the time it hit the target, it was moving, it had lowest momentum. It was slowed down to its lowest momentum. And so students had just learned about that in physics in their class, but they still did the the exercise wrong. So they didn't hit the target so that by the time it reached hit the ball, so that by the time it reached the target, it had slowed down, because they didn't factor in the idea that they had just learned about momentum. So it talked about, so even though if they had done an exam, they knew what the equation was, but then actually applying it in real life, it just never did consolidate for them. And so both the elementary students and the physics students failed at being able to do this particular task in this experiment. So that's engaging prior understanding. And I'm going to show you some techniques of what you can do regarding this in just a little bit. But then there's also the role of factual knowledge and conceptual frameworks. And so what this means is that in order for students to understand something and be able to be competent in it, being able to apply it, use it, recall it, what you need to do, what students need to do is have, first of all, factual knowledge. And then that factual knowledge needs to then, students need to know how to put it into a conceptual framework. And I'm going to show y'all a great example of this in just a second. But you have facts, but then how do they apply? What's the connection between them? How is it used? That's your conceptual framework. And then how do you, when you get new facts, how do you then organize them and put them into that framework as you learn new material or as you deepen your understanding? Okay. And then from that, from this structure, this scaffold of your framework and the facts and how they fit, taking that and then applying it, your highest level of thinking, applying it to new experiences. Okay. So a great example is this 1908 study where they had students, what they were doing is they were throwing darts to a target underwater, and the target was under 12 inches of water. There were two groups. One group was given an explanation of refraction of light. So whether or not as light causes the appearance of the bending of light through different densities causes the appearance of something to be shifted because the light rays bend. One group received an explanation of refraction, the other did not. They both were able to hit the target at 12 inches, but then when the target was moved to 4 inches of water, the one that had the explanation of refraction were better able to hit the target than the one that did not. So you're practicing, you're doing the activity, but if you don't know why something would change, what you're seeing and how you should adjust, you won't be able to learn what you need to do. So let me show y'all another example. This idea of factual knowledge is necessary as well as these conceptual frameworks. So this is nonsense words. So don't think that you need to know what these words are, okay? So last tourney, Flingeldobe and Pribben were in the birdling, treppering gloopy capels and cleaning burly greeps. Suddenly, a ditty strezzle boofed into Flingeldobe's trusk. So Pribben gaped, "Oh, Flingeldobe," he chifed. "That ditty strezzle is tunning in your grep." Y'all are like, what the heck? So let me ask you some questions. When did Flingeldobe and Pribben trepper? Y'all tell me, type into the chat. That's right, last Cerny. Good. What kind of capels did Flingeldobe and Pribben treppin? Yeah, gloopy, good. What did the ditty strezzle do to Flingeldobe's trusk? That's right, it boofed into, yeah. One of those words. And then what was Pribben's reaction? Yeah, he glaped and chifed. Yeah, okay, good. Next question. What do you imagine happened next? What happened next? I should have that meme of the kid going, Or let me ask you another question. Based on these incidents, why do you think that they went to BirdLink? Are they likely to return? And why or why not? And why can't you answer these questions? Number 5 and number 6. Why can't you answer those questions? You answered the first 4. Yeah, prior knowledge of the words, but pretend you knew what those words were. Well, yeah, so prior knowledge of the words, what else? Say you knew what the words were because you just answered those 4 questions. Yeah, it's missing context. You're missing the structure. You're missing the what we just talked about, the conceptual framework. So you have, yes, the actual meaning. So you have the knowledge that's in that paragraph, but you don't have the conceptual framework. So you need both. So the way that these interact, so the only way you can apply what you learned is if you learn it with understanding in the first place. So it's not that you have to have just facts or just big ideas. You have to have both of them for really good, true, deep learning to occur. So by remembering, in order to remember factual knowledge, that remembering is enhanced by having that conceptual idea, that scaffold of how they all fit together. And then that conceptual scaffold continues to be solidified and clarified when you get new facts to help then, clarify it better or support it, be able to transfer it to new situations. Okay. And then the third one that I want to mention is self-monitoring. So this is metacognition, how to teach students to employ metacognition. So awareness of what is needed of themselves in order to learn and remember. So this helps students take control of their learning. What are their learning goals? How do they monitor their own progress to them? What are their strengths and weaknesses in their learning? And so an example in 2002, students who were told, and y'all may know this, you may have done this in your class, if you have students do a self-explanation or an explanation to a partner, they actually develop better, deeper conceptual understanding than if they did not do that. So this is them seeing that they need to do this technique, this metacognitive technique, in order to better understand material. So let's do a practice of how well your metacognition is. So I'm going to give you a passage, and what I'm going to ask you to do is think about, after you read the passage, how will you rephrase that? How would you rephrase what the passage says? But instead of what it is that the content is saying, think about what strategies you're using to understand what you read. So here is the paragraph. I'm just going to let y'all read it. So if I were to ask you to rephrase what was being said in this 4-line sentence, what are you doing in your brain in order to think of how you would rephrase that? What is your mind doing? Yeah, breaking the sentence into separate parts. What are we talking about? Who's doing what? What are the overall takeaway is? Good. What else? Yeah, and what that is, I call that chunking. So there's lots of types of chunkings of things, but that's basically chunking, trying to figure out what each section is. Let's see, using prior knowledge of what would be a more effective sentence structure. Yeah, that's a great one. I hadn't even thought about that one. How would I rewrite this? Understanding what a serious literary critic is. Yes. I did literary criticism in high school. I loved it, but that's not where I am now. So that's awesome. So good readers would typically reread, back up several times or to grasp the meaning, do it in chunks. Poor readers typically would read through that. I don't get it. They don't ask if it makes sense. How could they make sense? Okay. So that's what metacognition is, thinking about even subconsciously, what do I need to do in order to understand something that I've been given? So let's look at some research-based metacognitive learning strategy. So I have an activity I'm going to have y'all do. This comes from this really great article, and I will post it in the chat or send it to you later, called Strengthening the Student Toolbox. And it's this American Educator article that is based on this 50-page paper about what techniques for studying works based on metacognitive strategies, cognitive and educational psychology. It's a great paper. It's really long. So here is this paper, the Strengthening the Student Toolbox, looked at 10 strategies, study strategies, and assessed based on a whole bunch of research, meta-analysis basically, of what worked and what didn't. And so what I did was I developed a little quiz from this, and I do this in my classes, especially my 100 and 200 level classes for majors and non-majors. So I'm going to ask you, these 10 techniques on the left, I want you to tell me, or actually kind of scratch on a piece of paper, scratch down what those are. So I just put into the chat of the actual effective study strategy quiz. So you can, do this on your computer, whatever you want to do. So highlighting What I want you to do is tell me whether highlighting, a passage, does it have low effectiveness for studying, moderate, or high? And I'll explain each of these in turn. So just write this down on your sheet, or keep a record of what you're writing down. Because what I will then do is tell you what the actual rating is, and you're going to score yourself. Rereading, so rereading a passage over and over, is that a effective study strategy? Low effectiveness, moderate, or high? Self-explanation, so you're explaining something to yourself, whether or not do you understand it, can you make sense of it? Also, self-explanation could also be explanation to someone else as well. Low, moderate, or high? Practice testing is what it sounds like, doing practice tests, practice quizzes, practice questions. Low, moderate, high. Summarization is where you're summarizing what you just read. Elaborative interrogation is where you're quizzing yourself on different aspects, just kind of going into depth on certain things, questioning yourself. Imagery is images. Effective for studying, low, moderate, or high. Distributed practice, we've talked about, where you're distributing a certain type of practice, whether it's problem solving or reading or whatever it might be, across time. Whether it's, every day, in the morning, in the afternoon, that's distributed. Low, moderate, or high. And then interleaved is doing distributed, but doing different things, different types of studying practice in between. And then keyword mnemonic, that's where you have Roy G. Biv, red, orange, yellow, green, indigo, violet. So the first letter being a mnemonic to remember a list of things. Okay, low, medium, or high? So now let me give you the rating from the research meta-analysis. So highlighting, what did y'all say was highlighting? Just a couple of y'all tell me what you rated, low, moderate, or high? Low, okay. Yep, that's correct. So it was low. Research says it's low. And so if you, as we're going through this, you can tally what your points were. So if you said that highlighting was low and the rating is low, you get 2 points. If you said that highlighting was moderate, since it's low, you only get 1 point because you're off by 1. If you said it was high, you get 0 points because you're off by 2. Okay. And I'll repeat that at the end. So rereading, low, moderate, or high, the research says it's low. And so highlighting, it doesn't work because you're just like, oh, pretty color, pretty color, pretty color, pretty color. You're not really paying attention. So moderate or high for reading, yeah. So a lot of people think that that works, but to really cement it, you need to be doing other things to consolidate it. Self-explanation, research said moderate. I think this goes to, if you can teach something, you really know it. That's one way to think about it. Although it's moderate because you have to make sure that you're correct or not. Yeah, so some of y'all said high, so the actual research shows moderate. So again, 2 points if you're correct, 1 if you're off by 1, 0 if you're off by 2. Practice testing, what did y'all say? It is high, y'all. It is so high. I'm going to show you the research. It is amazing. Summarization, what did y'all say? Research says it's low because you're summarizing, but are you actually cementing the detail that you need? Okay. Elaborative interrogation, moderate, because sometimes you don't know what questions to ask yourself. Imagery, what did y'all say? High. Okay. Now this one is context dependent. It depends on what's in the image, but research generally shows by just looking at a picture, it actually is not sure. It's not very good at cementing you need to be able to explain what you see in the image. Okay. Distributed practice, high. Research just is all over the place, high. Interlead practice is also high. Okay. And then keyword mnemonic, low. It helps you remember lists, but then do you understand what the list is? What are the details of the list? So go ahead and summarize, figure out what your points are. Again, if you were correct, you get 2. If you were off by 1, say you said low and it was medium, you get 1 point. Off by 2, you get 0. And so the percentage rating is Here's the percentage. So do your total points and let me know how many points you got out of 20 or what percent you got. And it's okay if you're low. That's why we're doing this. 60%. Okay. Yeah, that's pretty common. 60% is very common. 60, 75. Awesome. 75. I mean, when I do this with my students, they're like 9, 8 out, 8 out of 20. So less than 50%, not good. And that's why it's so important to teach your students of what works, of what is metacognition. So you can see that there are things you think highlighting your book works, doesn't. So don't spend the time studying by doing that. Okay. Okay, so let's look at distributed learning, just some of the research on it. It's called the spacing effect, where you have the information being spaced out or interleaved. So it's how that information is being repeated, not that it's being repeated one after the other in a block of time, but across time helps to really consolidate that information. Studying a new concept right after you learn it does not deepen the memory. Studying it an hour later or a day later does, okay? Retrieval practice, several of y'all mentioned this. There's a lot of studies that show that by just studying something, yes, you need to be able to retrieve it, but the best way to retrieve it isn't to study it again. So this research here, there was three different groups that either repeated studying and then were tested on how well they remembered it after 1 week or after 5 minutes. They were tested at once and studied 3 times and then tested once, and then studied once and then tested 3 times. The students who 5 minutes, those who repeated the studying did well. 1 week later, if you were tested multiple times, you remembered it better. So testing is retrieval practice. So the learner needs to be able to retrieve information from long-term memory, not short-term, for it to be effective learning. I think that's such an awesome thing. So great example of why multiple quizzes, weekly quizzes are better than one exam, a midterm and a final. So retrieval practice, space practice is better than that short-term repetitive practice. So testing is retrieval practice, and there's lots of research that shows that. So testing is not just measurement. I think it's so important to think about that. Testing, when you test, you're actually forcing your brain and memory to think about that in a different way, to form new nerve pathways in a different way. I mean, this is actually research that shows this, so that you're actually reorganizing your knowledge, and testing does this, or different types of studying skills, not just repeating what you have learned. So testing is better than just studying if you're going to be tested later for a delayed test. And so even with other types of retention strategies, testing improves learning better. It slows down forgetting. So cool. So some strategies you can use. Building up students' knowledge. We've talked about this. I want to get to some examples to show you all these things I'm showing you here. Sharing and talking about how you think, how you study, the way you categorize and just really deep think about things. Close reading, those are strategies, those are mental models. Normalize thinking about thinking. Start with quizzes, pre-lab quizzes, those types of thinking help either for new content or also for previously learned content. That's retrieval. Or having homework where they have to reconsolidate and revisit topics. That's still retrieval. It works. Building up actions that students can take in each subject area. So if they don't know what to do, give them guidance on what they should be thinking about. What would be the next step in this? Think about what you did. What would be the natural thing that would happen next? And then prompt learners on reflecting what they learned and how it worked, how well it worked. So let me show you some examples of these. So one of them is, how confident are you? What is your pre-knowledge? What is your preconceptions, misconceptions? I do this in my 700 level and 500 level courses. I'm teaching paleoclimatology this semester to a lot of students who are not marine geologists. So I do a survey, how do you rate your knowledge? I have no idea what it is. Minimal amount. I've read an article, I've had a class, superficial versus in depth. I am involved with this in my topic. And this dictates how much I teach a particular topic, but it also gets them to see, oh, I need to pay attention more to this content in class because I really don't know it. Retrospectives. So students write down what they think they know before they learn it, and then you go back and assess how well you knew it. So I do this with, learning about how water works and the ocean works. Why does ice float? When an iceberg melts, what happens to sea level? This one right here with winds. I have them, before we start winds, I tell them to draw the wind pattern on Earth's surface. Y'all, it is hilarious what I get. And then after we talk about winds, I say, okay, now draw me the pattern of winds and pressure systems on the Earth's surface. Okay. Exam wrappers, these are very common. There's a lot of examples out there online. So this is more not what did they learn, but what did you do to study? How much time did you spend? What level is the content being prepared? What can I do to help you? So they're thinking about what they need to do to think, how well did they study? Maybe I should be studying better. What did I need to do that I didn't do? You can do that as points on another exam. Guided reflections. I do this in my classes. My class wrappers are things I do after a class, after every 2 classes. What did you learn? What's some things that interest you? And this helps to really retrieve and consolidate. But then my larger percentage grades in these classes are reflections. Discuss the themes. We're talking about bathymetry and growth of technology. Discuss that in the context of what you've learned, incorporate examples, how you foresee the growth of geological oceanography. These are reflections, but they are depth reflections on retrieving that content and learning it. Okay. And then other classroom assessment techniques. You've probably heard of these CATs. These are active learning strategies. These are still metacognitive strategies. So things like one sentence summary, where I had students, we talked about how oil forms. Now, I want you to tell me in one sentence, who does what, when, where, and why about how oil forms. And that's a summarization, but that really is making them rethink things in different ways. Direct paraphrasing, which is this right here, using one-word sentences, describe the Earth's, how the Earth's surface, teaching to another student, how the Earth's surface and atmosphere formed. Concept checks, quick checks, lecture checks. I do that here. Here's a concept check of layers where they draw it out after we talk about it. Entrance tickets, exit tickets, if you've heard those, these are all metacognitive strategies that you can use. Okay. So metacognition is the secret ingredient to really good learning. It makes sure that students are doing more depth of learning, more meaningful learning, self-aware of what they need to do. It is a compass that guides them through those challenges because they start thinking about it on their own. They being more proactive. And it shows them that they're actually growing and there's potential in being better and being a better student and just learning more about it. So I want to ask you, from what you've heard today, and you've heard a lot of strategies and ideas, what do you think you're going to do or perhaps change in your instructional strategies moving forward? What are some things you'd like to incorporate in what you teach, how you teach, how you interact with students, coaching, all of that? Go ahead and type that into the chat. Yeah, active learning. There's a webinar recording on active learning in our YouTube channel. Self-reflections, yep. Changing things with myself. Oh, I love that. That is awesome. This more thought process modeling and retrospectives. Yes, absolutely. I mean, thinking about thinking. How do you process thinking? I want to go back to this. Y'all, if y'all want this effectiveness of study strategies, I can send it to you. Let me see if I can pull it up really quick. Maybe not a grade that counts, but the memory fetching. Yeah, that's cool. And quizzes before each class. Now you have good reasons. Yes, now you know why the things that you do, being transparent with your classes, why to do the things that you do. All right, so here's the key in the chat. And so if you do use those effective study strategies, of course, credit me, but I am happy for you to use them however you want them. Understanding, never thought of understanding your strengths and weaknesses at a metacognition. Yes. Oh, that's really a great point. Yeah, that's awesome. Okay. Thank y'all for being here. I hope that you got some good ideas. I would love to hear how you have incorporated these later on. If you do, I'd love to hear stories. Y'all are welcome. It's a fun one to do for me.